Okay, so to solve this on the reverse path, I'm going to go to XR1 and configure a tunnel on the way back. Okay, so we'll say that we have interface tunnel -TE, and we need to say what is the IPv4 address. This is going to be unnumbered from the loopback. We need to specify the destination. Destination is router 3. We're going to do an auto route. That's going to put the route in the table. We'll say auto route announce. And then we need to specify our path option. Okay, path option is going to be dynamic. So if we show config, this is going to be pretty much the minimum tunnel config. No shut commit, and then if we look at the show IP interface brief, if we see the tunnel is up, it means signaling worked. If we look at the routing table, to how do we route to 3333, we should be pointing out the TE tunnel. Okay, so now let's check that trace route again. Okay, now it's bidirectional. Again, because the ICMP, or excuse me, the UDP pings that are going for the trace route has to go all the way to the end of the LSP, and then it gets re-encapsulated back on a hop-by-hop basis. So when we were looking at problems with L3VPN, trace route's not really a great troubleshooting tool, because if the LSP is broken, you get this type of output where you just hit the first hop and then you don't see anything. Okay, so now what's happening is that the traffic is leaving in this direction and that it's coming back in this direction. So we have end-to-end reachability. Now from router 10's point of view, again, it should no longer have reachability because we do not have any LDP-based LSPs in the core. So solution for this from a traffic engineering point of view would mean that we would have to configure a tunnel that is going from 2 to XR1, from XR1 back to 2, from 2 to XR3, and from XR3 back to 2, assuming that we want to be able to route in both directions bidirectionally. Okay, other simpler solution would just be to turn LDP on. Because we're already running IGP in the core, we already have OSPF or ISIS running. If we enable LDP autoconfig, we automatically have that one-to-one binding between the IGP routes and the LDP bound labels. Now, where this problem case is going to come in, other than when we're doing the end-to-end PE to PE tunnels, so right now we have the PE as router 1, doing a tunnel PE all the way to router 3, is when we do a tunnel that either goes from the PE to a P router to a PE router, or where we go from P to P. Okay, basically a TE tunnel in the core. And again, the typical reason why you would have this in a real design is for traffic engineering, either link or node protection. That we're sending the traffic from the access edge to the aggregation to the core of the network, and we want to protect the core links against failures. So let's say that we have a tunnel that is going from router 1 to XR3, and we're using this for protecting, let's say, the link that is going between these two. Okay, so this is our primary path, and then our backup path goes something like in this direction. Okay, we'll look at the specific configuration of that portion later where we're doing the link protection or the node protection, but the point here is that we're doing a tunnel that does not go end-to-end between the L3VPN provider edge routers. So what I'm going to do instead on router 1 is we're going to modify what its current tunnel config is going to be, and we're going to change the tunnel destination. Okay, we're changing the tunnel destination from router 3 over to XR3. So on router 1, let's look at the show run interface tunnel 0. And we're going to set on tunnel 0 not to do an auto route, and we're going to change the tunnel destination to 13, 13, 13, 13. Okay, the tunnel comes up. We should see the line protocol come up. That means signaling was good. And we're now going to do a static route for router 3 to point out this particular tunnel, to go to tunnel 0. So what this basically now means is that 1 says to reach 3, use the tunnel that goes towards XR3. The point of this being is that if we have some sort of bandwidth reservation or some sort of link or node protection, we could say use this as the primary path to get to 3, but then XR2 configures another secondary tunnel that is protecting against this link failure. So if this goes down, this is going to be transparent from router 1's point of view, that XR2 is going to move the traffic in this direction, it goes around the failed link, we get to XR3, and then we're able to go to the final destination, which is router 3. Now, what is going to be the potential problem of this, though, is that when we look at this from the perspective of the L3VPN customer, okay, which is router 6 here. So 6 now goes to send traffic to the destination, and it's now getting black holed in the core of the network. Okay, let's do this as a ping, and we're going to do the same thing as we did before, just one repeat for the packet count. And let's now look at this from the packet capture in the middle. So we're going to do the single ping, and we want to know how many packets went on the outbound path. We can see it was 1, 2, 3, 4 hops, where in our actual design, it should have been 1, 2, 3, 4, 5, 6 hops. So somewhere along the path, specifically on hop number 4, it looks like the packet was lost. Okay, so let's look at specifically what's going on in terms of the encapsulation difference between these. Let me zoom this in a little bit here. Okay, if we look at the first packet, this should be the one that is IP only because it's coming from the original customer edge. Customer edge is not running MPLS. Okay, it goes out to the second hop, which is still part of the customer network. They see this as just a regular IP packet. Next, it gets to router 1. Router 1 is putting a 2-label stack on the packet. It has the outer transport header, 16012, and the inner VPN label. This is the one that came from VPN v4 BGP. This top label, this is the one that came from MPLS TE. We push the labels on, we forward the packet on, and get to the next hop. The next hop says there's only one label. Okay, notice where this specifically happened. It was at hop 1, 2, 3, 4, where in our particular design, this is 1, 2, 3, 4. It happened on XR2's forwarding outbound towards this guy. Okay, and if we look specifically at the MPLS forwarding table of XR2, and we want to know what is it doing when it receives a packet inbound that has label 16012 as the outer header, as the topmost label. So from XR2, if we look at the show MPLS forwarding table and look for 16012, it says we're going to do what? We're going to pop the topmost label. So remove one label from the stack, and then continue to forward it out towards whatever the outgoing interface is. In this case, outgoing interface is 1213, so it's popping one of the labels that's going this direction. So again, the packet came in from this way. It had a 2-label stack on the frame. Then when XR2 forwards it out, it only has 1 label in the stack. Why is this going to be a problem here? Well, think about it. Who's the destination PE that we're trying to reach? Only router 3 knows about the route to the final destination. This guy doesn't know, this guy doesn't know, and this guy doesn't know. The problem is that XR3 doesn't know that VPN label because it's not participating in that VRF. So essentially what's happening is that the topmost label is being popped 1 hop too soon. So it's a problem that's related to penultimate hop hopping. The reason this is the case is that the destination of the TE tunnel is 13's loopback, or XR3's loopback. From XR3's loopback, when it does a TE allocation to XR2, it's going to say the label value is implicit null. Because XR2 in this case is directly connected to XR3, it is the penultimate hop. XR2 is then going to do a regular allocation over to router 1, which in this case was 16012, saying that when router 1 takes any packets and they go out the TE tunnel, we need to push this label on top. It also was pushing label number 20, which was the one that came in from the VPN v4 advertisement over to router 3. But now again, the issue is that since XR3 is not participating in this VPN, it's getting exposed to a VPN label that it doesn't know. Now, we did not see this problem in the previous case where the TE tunnel was going from PE to PE, because the destination of the tunnel was also the device that had the VPN v4 label. So there's a couple possible solutions to this. One is that we can move the tunnel so it points to router 3 as opposed to pointing towards XR3. Okay, that was basically the first case where everything was functional, that it was going PE to PE end to end. Okay, the other possible solution is that we need to add an additional label to the stack so that when XR3 receives it, it does not see the VPN label, it needs to see a transport label. This is the case where we would run LDP inside of a TE tunnel. So essentially what's now going to happen is that router 1 and XR3 are going to form what we call a targeted LDP session. Okay, a targeted LDP basically means it's a multi-hop session, just like multi-hop BGP. So they already have IGP reachability to each other. They're running OSPF or ISIS in the core. And since LDP is TCP based, we can route the traffic point to point between them. Inside of the TE tunnel, we're then going to do a label allocation for any final destinations that we're trying to reach out there, which in our particular case, we're trying to reach the loopback of 3. So what this now means is that when router 1 goes to allocate the labels as we're pushing the traffic in the data plane, we're going to put label number 20 on the bottom. We're going to put 16012 in the middle. Okay, so this one is the VPN label. This middle one is the TE label. And then we're going to put a new label on the top that is going to be coming from LDP. Now, the change of this from router 1's perspective is trivial. It's only one command. We simply say MPLS IP on the TE tunnel interface. It's enabling LDP on the port. But from XR3's point of view, it has to be configured to listen for this session. Because normally when you establish LDP adjacency, you first need to discover the neighbors based on the UDP hellos. So we're sending those UDP multicast 224.0.0.2 to all the routers. The routers figure out, yeah, I'm on the same segment as you, let's run LDP, and we form a TCP adjacency. But in this particular case, since router 1 and XR3 are not directly connected, they won't be able to receive UDP hellos between each other. So the way we do this is on XR3 is we need to say, I believe this is under MPLS LDP mode, is we need to form a targeted session. So I believe this is going to be targeted. Let's see, it says this is deprecated. Let's see, what does it change this into if we commit the config? Let's show run. And it accepts the config. Oh, it must be under the AFI is why it's deprecated now. Okay, so let's go to MPLS LDP. Look at the question mark, neighbor. Okay, neighbor 1111. Targeted session. Okay, so now XR3 is trying to start a session to router 1, and it's also listening for the session to come in. Let's commit the config. And if we show MPLS LDP neighbors, we should see that we're going to eventually have a connection going to router 1. Okay, on router 1 on the TE tunnel, we're going to go to do show run interface tunnel 0. We're going to go to interface tunnel 0 and say MPLS IP. Okay, that's turning LDP on. We now have an adjacency up to 13. So from XR3 show MPLS LDP neighbors, we should see that we have a session to 1. And it says that this is a targeted session. Okay, if we now look at from XR3's point of view and look at the show MPLS forwarding table, what we're going to see is that there is going to be a new label that we're going to be using in the stack as we receive traffic in the tunnel. Okay, and the easiest way to see this is just to look at the data plane. So let's go back to router 6 and let's clear this capture out. And let's do the ping again. And we're going to ping with just one packet. Okay, well, looks like we didn't get any further yet. So we got to, let's see, we do have another label though. We have label 16,001 is now in the stack. Okay, so this is on the fourth hop. The fourth hop in this case is, again, 1, 2, 3, 4. So the packet is now going out to XR3. XR3 is receiving this ingress with label number 16,001. Okay, the VPN label is now hidden, so XR3 doesn't need to know about the final destination. But it does need to know about what is the exit PE out of the network. So from XR3's point of view, if we now look at the show MPLS forwarding table and we look at what happens when we get ingress 16,001, what's the problem? It says it's unlabeled as it goes out, right? Okay, we talked about what these different outputs mean in show MPLS forwarding table, that if it says pop tag or pop label, it means you're removing just one label from the top of the stack. But if it says no label or unlabeled, it means you remove the entire stack before you go to forward it. So the problem now is that since we did not have underlying LDP in the core of the network, we have this additional hop between XR3 and router 3 that's not running MPLS. We're not allowed to forward label packets out that interface. Now there are multiple solutions to this again. We could run LDP on the link between them. We could run a one-hop TE tunnel between them. We could do eBGP, IPv4 labeled unicast between them. Simplest solution though is going to be just to enable LDP. So as long as we have a label on this link going to 3333, then we should be able to push or continue to send the label stack on, and then router 3 will be able to decapsulate it. Okay, so let's say that under MPLS LDP, we're now enabling LDP on that particular port. And then likewise, from router 3's point of view, if we show IP interface brief, this is going to be gig 1.313. We'll say on that port, MPLS IP. Okay, that should cause us to form an LDP adjacency to 13. And if we now send our ping again, we should be able to get end-to-end, which we can. Okay, but let's now look at the data plane on those additional hops. So first off, it came in as unlabeled traffic. Okay, this was coming in from the CE. The CE sends it to router 1. Router 1 now is putting 3 labels on the stack. It has the underlying VPN v4 label. It has the TE label, which is saying that the intermediary destination is XR3, and then the outer transport label is actually, no, 16,001, that's going to be the one that came from LDP. Okay, it's actually the opposite of what I said before. So let's look at from router 1, if we show MPLS forwarding table, where did it get 16,001 from? This is the LDP label. The outer label, 16,012, this is the one that came from RSVP. Okay, so the stack actually would look like this, VPN v4, then LDP, and then TE, because LDP is running inside of the TE tunnel. Okay, previously I'd swapped these two. So this means that router 1 is adding the VPN label, it's adding the new LDP label, and then it adds the outer TE label. Okay, now it goes to the next hop, which is in this case XR2. XR2 is popping one of the tags, which it popped off the TE label because it says, I'm directly connected to the tunnel destination, which is XR3. We now remove one of the labels, we expose 2 of them. The second label that we've exposed, the topmost label, this is the one that came from LDP. Still underneath there, we have the VPN v4 label. When XR3 now gets this, it says, how do I get to 16,000, or what am I going to do when 16,001 comes in? If we now show MPLS forwarding table, it says 16,001 comes in, and we should pop the top label, but maintain the ones underneath there. So this means that we're going to delete 16,001, we're going to leave number 20. Okay, number 20 should now go into the next to last hop, which this is router 3. Router 3 does a lookup on this and says, this is one of my VPN v4 destinations. If we show MPLS forwarding table, look at the ingress number 20, Ingress number 20 is part of the VPN, and it's going to go out the CE-facing interface. Now, we would also see that the same would be true if we were running L3VPN over MPLS TE. That if we're forming a targeted LDP session end-to-end, like between router 1 and router 3, and then we have TE in the middle, if the traffic engineering tunnel is not end-to-end PE to PE, that's the case that we're required to run LDP inside of the tunnel. Now again, the simpler solution though was to either run LDP everywhere or to make sure that the TE tunnels are going end-to-end between the PEs, not going from P to PE. Okay, so we wanted this case, PE to PE. The problem cases are either PE to P, like 1 to XR3, which is what we had here, or if we did vice versa, if we did P to PE, or if we did P to P. So if we did a tunnel that's going between XR2 and XR3, let's say we go this direction, and XR2 is saying use that tunnel in order to reach router 3, the problem is that the label would be popped one hop too soon, and router 2 is going to say, well, I don't know that final destination, and then ultimately the traffic is going to get black holed. Now, where this is documented, there is I believe, a tech tip that talks about this specific problem, which is, let me just search for this because I'm not exactly sure what the document is called. It would be Cisco LDP over MPLS TE. I believe it is this one, implementing MPLS VPNs over TE tunnels. But this is not part of the documentation set. This is part of the tech tips, which is basically, they're describing the same case here, that the problem is when you go from PE to P or P to P, then the end result is that you need to enable LDP in order to allow the VPN label not to get exposed. So I'll go ahead and post the link to this particular document. But if you just search for it, it's implementing MPLS VPN over TE tunnels. Okay, questions on this case as to why it is a problem to begin with or what the proposed solution for it was. And if we recap that config real quick, the only change that I made on router 1 is just to enable LDP on the tunnel. So MPLS IP goes on the TE tunnel. Then on the other end, who is the destination of the tunnel, they have to accept the targeted session. So under LDP, the neighbor is a targeted neighbor. The equivalent iOS command of this would be in global config. It's the MPLS LDP neighbor, whatever the destination is, and then targeted. No, it's like targeted hello accept. MPLS LDP targeted LDP. Let me search for that. MPLS LDP discovery. MPLS LDP discovery targeted hello accept. So this is basically saying someone on the other end, when they send a targeted session to you, you automatically respond towards it. Where the other option is just to configure a neighbor towards them and say that it's a targeted session, that it's a multi-hop session. We'll see that when we look at L3VPN, when we are running either L3VPN point-to-point with any transport over MPLS, or whether we're running it point to multi-point with VPLS, you'll automatically accept the targeted hellos, because LDP is the way that we signal the layer 2 VPN label, or what's referred to as the pseudo-wire label. But in this case would be the same problem if we did L3VPN over TE, that you would still need to run LDP inside of the TE tunnel in order to add that additional label to the stack.